Okay, in the last video, we were working with this partial fraction expansion, and we had it down to here. And what we had to do after this, of course, is multiply through, and then, so we went through the algebra and did that, and then equate coefficients. There's no x cubed on this side, so a plus c has to be 0. There's no x squared on this side, so this is going to be 0. This is times x, so this has to be minus 2. And here's a constant, and so b minus c plus d has to be 4. So we wrote all those down here. We have 4 unknowns, a, b, c, d, and we have 4 equations. And if you go ahead and do the algebra, a, that comes out to be equal to plus 2. So this is 2. B comes out equal to 1. C comes out to minus 2. And D is also 1. So, let's make some room here. This expression equals 2x plus 1 divided by x squared plus 1. And we'll have minus 2 over x minus 1 plus 1 over x minus 1 squared. So we seem to be chiseling away to get this into a form that we can solve. We have this equals this plus this integral, and this we have just expanded to this. So let's make some room at the top. We want to keep this, and everything else can go in between here. Okay, so it looks like we're going to have our original integral here is going to come out equal to, we have this, so it's going to equal the integral of x plus 1 dx, and then we'll have plus this integral here. All of this now is from this right here, from this entire integral. So this integral is now 3 integrals, this one, and this one. So we're going to have plus the integral of 2x plus 1 divided by x squared plus 1 dx minus 2 the integral of dx divided by x minus 1, and we're going to have plus dx divided by x minus 1 squared. So it looks like finally we might have the upper hand here. These seem like they're quite reasonable integrals here. For this we would have Let's do this. Let's just call this whole thing u. Call that u. du is that, so this will be 1/2 u squared, or 1/2 x plus 1 squared. Let's write this a little bit neater. With this integral here, call the x plus 1 u, dx is du, so that's 1/2 u squared, so we have 1/2 x plus 1 squared. And let's see, we've got 2x divided by x squared plus 1. If we say, let this be equal to, well, let's see, if I call this u, du would be equal to 2x. Okay, we're going to split this into two integrals here. We've got the integral of 2x over x squared plus 1 plus, this is dx, plus we're going to have the integral of 1, or dx, over x squared plus 1. Let's see here, we're not being very neat about this. This integral here is going to be the integral of dx over x squared plus 1, 2x dx over x squared plus 1, plus dx over x squared plus 1. This is x minus 1 here. Alright, 2x over x squared plus 1. Call that u. du is going to be 2x dx. That's what that is. So this is going to be plus the natural log of x squared plus 1. And hopefully you recognize this. That's the inverse tangent of x. We have plus the inverse tangent of x. And here we have dx over x minus 1. If I call this u, that's du. That's minus 2, the natural log of x minus 1. And finally, we have our last one, x minus 1 squared. And let's write it like this. Integral x minus 1 to the minus 2 dx. Call this u. Let u equal x minus 1. du equals dx. Now we have the integral of u to the minus 2 du, which equals u to the minus 1, divided by minus 1, and this equals minus 1 over u, which is x minus 1. So this integral is no problem. Minus 1 over x minus 1 plus a constant. If we haven't made any mistakes, that should be the solution. Let's just go back and check ourselves here. First integral. X plus 1, call that u. du is dx, that's 1/2 u squared. X squared plus 1, call that u. du, well no, we broke this up into two integrals. We had the integral of 2x over x squared plus 1 plus the integral of dx over x squared plus 1. Call that u, because with a dx. If I call this u, du is 2x dx. So this is the natural log of u, which is this. So we have that. This is the inverse tangent of x. We have dx over x minus 1. If I call this u, du is dx. So it's du over u. That's minus 2 natural log of x minus 1. And then with this here, this is real simple to do. This is the u du substitution, and we get this. So finally, there it is, our monster integral. This is equal to this. So we had to do a log division, and then that set us up where we could deal with this integral, which we could handle because we could factor that with synthetic division, and then we had to expand it with partial fractions, and then that gave us these terms, and then after that it was pretty straightforward to integrate. So it's a long expression, but we had a lot of steps in between, so we shouldn't be surprised about that. But you can see, even with a real complicated integral, take your time, work your way through it, follow through the different steps, and you should be okay. Okay, that's it for now. Come back and join us for some more videos, and we'll see if we can solve some more problems.